Hey everyone, and welcome to The Explainer. So, synthetic polymers. Is this a topic that's kind of giving you a headache for your SPM chemistry exam? Well, you've come to the right place. Over the next few minutes, we're going to break it all down and get you totally exam ready. Let's get started. Do you know that feeling, right? The exams are getting closer, you're staring at your chemistry textbook, and it all just feels stuck? Yeah, we've all been there. But trust me, mastering polymers is way easier than you think. Okay, before we get into the nitty-gritty of the chemistry, I want to let you in on a little tutor secret. Look, the absolute best way to revise isn't just reading and rereading, it's all about active learning. And you know what the best kind of active learning is? It's grinding through those past year questions. That's why I always recommend MCQ SPM. You can find it on the web at www.mcqspm.com or just download the app. It is packed with real questions that will make these concepts stick in your brain for good. All right, let's do this. Let's really get into it. To get a grip on synthetic polymers, we've got to start right at the beginning. What even are they, and what makes them so incredibly special? So, what is a polymer at its most basic level? Honestly, it's just a really long molecule. I love this analogy. Think of a train. Each little carriage, that's a small molecule we call a monomer. Now, when you link up hundreds, maybe thousands of those carriages, boom, you've got the whole train. And that is your polymer. And it's this super long chain structure that's the secret sauce, right? It's what gives these synthetic polymers all their amazing properties. Because those chains are so stable, these materials are usually non-reactive. They're tough against chemicals and heat, and a lot of them are surprisingly lightweight. It's a special mix of features that makes them so useful in our world. Now pay attention, because this is the single most important idea for your exams. Chemists and engineers don't just pick a polymer at random. They choose a specific polymer for a specific job because of its unique properties. It's literally all about matching the right material to the right mission. Let's check out a couple of classic examples. Okay, let's look at our first case study. Nylon. Two of its killer features are that it's super lightweight and it's really water resistant. This is mostly thanks to the strong bonds that hold its monomers together, giving the final fabric incredible strength without weighing it down. So, just stop and think for a second. If you're a designer and you need something strong but light and it has to keep the rain out, what are you going to make with it? Yep, you got it, umbrella canopies. Nylon is perfect. It's strong enough to handle wind, light enough to carry around easily, and water-resistant enough to keep you bone dry. It's a perfect match between the polymer's properties and the product's purpose. All right, let's switch gears and look at a totally different material with a whole other set of skills. This is styrene-butadiene rubber, or SBR for short. Its superpowers? Incredibly high abrasion resistance, that's wear and tear from friction, and just fantastic durability. All right, put your engineer's hat on again. If you've got a material that can take a beating, constant rubbing, scraping, all that friction, and just not fall apart, where would you use it? What kind of products need that toughness? Bingo! Shoe soles and, of course, vehicle tires. Think about it. Both of these things are constantly grinding against hard, rough surfaces. SBR's amazing durability and resistance to wear are exactly why it's the #1 choice for these tough jobs. Okay, so understanding these properties? That's half the battle won. Now, for the other half, let's see how we can use this knowledge to absolutely ace a typical SPM exam question. We're going to break it down just like a tutor would. Let's look at a real question. This is straight out of a past paper. So a person who makes decorative glassware has a problem. Their stuff is too fragile. It keeps breaking. They need a replacement material that is, and this is key, transparent, but not fragile. So this is how you should break it down in your head. This is the thought process. Step 1, pull out the keywords. Here, they're transparent and not fragile. Step 2, you got to dig into your memory bank. Which polymer did we learn about that's famous for being a strong, clear substitute for glass? The name that should just pop into your head is PMMA, Polymethylmethacrylate. It's the perfect fit. And the answer is, of course, Polymethylmethacrylate, which you probably know as Perspex. Okay, and here's the classic mistake I see students make all the time. Please don't do this. When you're under pressure in the exam hall, it's so tempting to just write down a polymer you remember, like, I don't know, nylon. But that's not right. You have to go back to the key words and find the polymer that is a perfect match for those specific properties. No guessing.
So we've seen how awesome and useful these polymers are. I mean, they're everywhere. But, and this is a big but, to be responsible scientists, we have to think about the whole life cycle. What happens when we're done using these things?
And this right here shows you the huge difference. Natural rubber, the kind from trees, is biodegradable. That means bacteria can break it down and it returns to nature. But synthetic rubber, totally different story. It's non-biodegradable, which means it sticks around in our environment for a very, very long time.
And this, as you can imagine, leads to a massive environmental problem. Just think about all those SPR tires we were talking about. Once they're worn out, getting rid of them is a huge challenge. They just pile up in landfills, creating pollution that lasts for generations. Now, there are some clever solutions popping up, like recycling them into fuel, but the basic problem that they just don't go away is still there. And this all leads to a really big, really important final question that I want to leave you with. These materials have literally built the modern world, but they've also left us with some serious challenges. So, as the next generation of scientists and engineers, the real challenge, the big question for your generation is this: how can we invent the next wave of materials to be not only powerful and useful, but also sustainable? That's the challenge that awaits you.